Welcome everyone. So in today's lesson, we will be actually interfacing Arduino Uno with an external LED. So we just did our last session, and in that we interfaced it with the onboard LED and we wrote a whole blink program. So this time we're going to do the same program, but we're actually going to use an external LED. So one of the main focus of this lesson will be the circuit diagram. So how will the circuit look like? So right now we're on Tinkercad, and let's see how it will look like. So first of all, we will need our most basic and most important component, that is the Arduino Uno. So let's just drag this into our workspace. Next, we will be needing an external LED. So let me just search for LED right here, and let's just take this red LED. So now we will be using a breadboard. So what is a breadboard? A breadboard is basically a rectangular piece which has tiny holes in it, and these holes are connected. So it is very beneficial for electronics prototyping. So let me just show you what it looks like. So breadboard. So basically this is a breadboard, and all these connections on the inside of the breadboard, these which are the green lines, what this indicates is that all these connections are common. That means if I plug the LED over here and a wire over here, it means that they are connected. Similarly, on the outside, these lines are common, which means that if I supply, let's say 5 volts over here, then I'll get 5 volts over here as well. So this is really beneficial in, prototyping. You can always attach all your components of the circuit over here, and a breadboard is something that is typically used by all activities in electronics for prototyping. So let's just get started. So as I told you before also, what is the cathode and the anode of the LED? So as you can see, this is the anode, and the anode being the positive terminal will be connected to the Arduino pin. So let's just connect this to the breadboard first. So first of all, we'd like to ground the cathode. So this is the cathode and here is the ground on the Arduino. So let me just connect this, and Tinkercad is really easy to use, and you can just connect it simply by clicking it and then just placing it where you want to connect it. Also, I would like to clean up these wires a bit so that they're not that, I would say, to give it a cleaner look. So this is what it will look like. Let me just do this really quickly. We'll also be needing another component to make our circuit work. So that'll be a resistor. So basically, why we are using a resistor? It's because we want to minimize the current that is supplied by the Arduino Uno so that the LED isn't damaged. So we'll be using a resistor here. So I'll just rotate it quickly, and let's connect the resistor to the anode, and then we'll connect the resistor other leg to the pin that we're going to program on the Arduino. So let's say we're going to program pin 8. So let me just connect it to the pin 8 on the Arduino, and let's give the color of this wire as blue. So usually we give the color of the wire which is connected to the ground is black, which is connected to the VCC, which is the voltage that we're supplying, as red, and all the signal wires are either blue or green. So we're connecting it as blue over here. So let's just clean up the circuit a bit and actually upload the code, write the code, and run a simulation. So let's go to the code section, and over here, let's go with text-based first. So over here, we are going to use our pin 8 as the output where the LED is connected. So I will just change this as 8. This is quite similar, if not completely similar, to the program that we just wrote. So that's why I'm not going to explain you the flowchart all over again. But it is exactly what we want to do. We want to turn the LED on for 1 second, wait for 1 second, turn the LED off, wait for another second, and put this in a complete loop. So as discussed before, our LED is connected to pin number 8, and that is why when we write pin mode, 8 is the pin and output, as we are sending it a signal to turn on and off. In the void loop, we'll be writing digital write 8 as high, then we're waiting, okay, delay for 1000 milliseconds, that's great, and then digital write 8 low. So I believe this code is perfect, and let's start the simulation and see what it looks like. So now that the simulation has started, You can see over here that how the LED is blinking at intervals of 1 second. And another cool animation of Tinkercad is that they join the power adapter of the Arduino. That is something that is nice, makes it look clean. And let's just take a look at the block-based approach as well. So as I go to the blocks, it's rather similar. First of all, we'll be setting pin 8 where our LED is connected to high. So let's just choose pin 8. Then we're going to be waiting 1 second. So let me just delete this entire portion rather. Then we go to control where we'll choose wait 1 second. Then we'll be setting up pin 8 to low. And finally, we'll be delaying it for 1 more second. With this out of the way, the code looks good. Let's start the simulation again. See what is the output this time. And yes, the LED is blinking once again at intervals of 1 second. So over here, we learned what is the circuit diagram for interfacing an external LED with the Arduino Uno. And we learned how to use a resistor, what is a breadboard. So moving on, we'll be studying all our sensor attachments in this very manner, learning about the circuit diagram first, learning about the functionalities of all the different components, then talking about the code. So this is how we will work in a very organized manner. So one more thing that I would like to show you is how we can make our code even cleaner. So what we can do over here, before the void setup function, we can create a variable called LED, which will store the pin number where the external LED is connected to the Arduino Uno. What I mean by this, let's create a variable called LED as int LED is equal to 8. What I mean by the int over here is that this variable is of integer type, as the pin number is also an integer. So with this out of the way, what we can do here, when we say pin mode 8 output, we can say pin mode LED output. And all over the code, we can change it to LED. So let's just say that due to some functionality or maybe some technical error, you connected the external LED in a big circuit to pin number 7. So you'll have to go through the code all over again and actually change all the specific locations. So in order to avoid that, what we can do is create an integer variable named anything. Over here, we're just taking it as LED and actually assign it the value of the pin number where the external LED is attached to the Arduino Uno. That is what I've done here. And let's see how the simulation looks like now. As you can see, every 1 second, the LED turns on. So with this out of the way, I feel really confident that we have learned how to interface an external LED with the Arduino Uno. We've learned what a breadboard is, we've used some rather electronic components over here. And moving on, whenever we are going to talk about other peripheral attachments, such as the various sensors that we're going to cover in the following sections, we'll be using a similar approach where we'll actually talk about all the components in detail, where we'll actually build the circuit together, and I'll actually explain the code to you line by line for your deep understanding.